Okay, so this mini lecture is on unit conversion, and unit conversion is just a technique we use in order to do a variety of things, one of which may be describe a physical quantity in a different unit, something that's more familiar to someone else. For example, here in the United States, we use pounds and inches and that system, whereas in other countries they use the metric system. So being able to talk about similar items in those two different units, we have to convert between them. Or perhaps we're doing mathematical manipulation, and when you do addition or subtraction, the units have to be in the same unit, or you can't add them or subtract the numbers together, and so you might need to convert units in order to do the math that's required for whatever situation you find yourself in. So what is the premise of unit conversion? It really is just multiplying a variable, physical quantity, by a representation of 1. And we know that when we multiply by 1, it doesn't change anything about the quantity. And that is really the basis of unit conversion. So let's imagine that we have an object that is 30 centimeters long. Well, 30 centimeters is about like this. It could be described in a variety of different ways. This length can be described as inches, or this length could be described as meters. So how do I go from this 30 centimeters to how many inches does that equal, or how many meters does that equal? So let's look at those two conversions. Well, it's still the same object, so I can't change anything about the magnitude of that object's length, so I have to only multiply that object by 1. So how is that? Well, we know that 1 inch is equal to 2.54 centimeters. Those are equivalent lengths. 1 inch is equal to 2.54 centimeters. If those two values are equal, if I write them as a ratio, this quantity equals 1. This value and this value are identical quantities. When I divide two identical quantities, I get 1. So multiplying anything by this ratio also gives me 1, or is 1. It doesn't change anything about it. And that's how I can do my unit conversion. So 30 centimeters times 1, where my 1 is 1 inch over 2.54 centimeters. There is 1 inch in 2.54 centimeters. Will give me, I don't have a calculator, will give me, now I just do my straight multiplication, 30 divided by 2.54, 30 divided by 2.54. Numerically, I have 11.81, and in unit math, the centimeters on top cancels with the centimeters on the bottom, just like division, and I'm left with inches on top. So 30 centimeters is equal to 11.81 inches. What about meters? Well, if I have 30 centimeters, I need my conversion of 1, my unit of 1, my amount of 1 that's going to convert it. That relates. Centimeters is on the top here, so I want it on the bottom. I want to end up with meters on the top. So my equivalence between meters and centimeters is 1 meter is 100 centimeters. Those are identical. And so 30 centimeters converted to meters is 0.3 meters. My centimeters cancel, and I end up with 0.3 meters. So that's our basics for unit conversion. We're just essentially multiplying by 1, using the relationship between the two units as my factor to multiply the variable I'm interested in, the physical quantity I'm interested in. And we want to keep in mind that if I start with 1 unit, to get rid of that unit and put it into a different unit, if centimeters is on top, I put centimeters on the bottom and do my ratio with the unit I want on top. If centimeters were on the bottom, I'd put centimeters on the top and do my ratio with units I want on the bottom. So let's look at another example where it gets a little bit more complicated because we also have to consider what happens if our unit has power. So let's imagine that, we'll just do a complicated example together, more complicated example together, that I have a car that's going 30 miles per hour, so 30 mph. And I want to know, well, I work in a discipline that uses the metric system. So how much is this in meters per second? So 30 miles per hour in meters per second. So we'll do that first, then we'll do a power one. So now I have two units that I have to convert. I need my miles to end up as meters, and I need my hours to end up as seconds. So 30 miles per hour. The first thing that we can do is we can look at a conversion between miles, and I'm trying to get to meters. And I don't remember the meter conversion very often, but I do remember the miles to kilometer conversion. At least I think I'm going to remember it correctly. I know that there is, which one's bigger? Miles is on top, so I want to put miles on the bottom. And I'm going to convert first to kilometers because that's the conversion I know. In 1 mile, we have 1.608, I think, kilometers. I do have my computer next to me, so let me just check that conversion. Miles to kilometers. 609, I was close. So 1 mile is 609 kilometers. Now, I don't want miles, I don't want kilometers, I want meters. So kilometers is on the top, so I'm going to put kilometers on the bottom and meters on the top. And I know that there are 1,000 meters in 1 kilometer. So again, those two are equivalent values. I then need my seconds. Well, hours is on the bottom, so to get rid of it, I put hours on the top. And I do know the conversion between hours and seconds, so in 1 hour, I have 3,600 seconds. Now, before we plug all the numbers into our calculator, we want to make sure that our units are going to end up with meters per second like we have. So, miles on the top, miles on the bottom, it goes away. Kilometers on the top, kilometers on the bottom, it goes away. I'm left with meters on the top, hours on the bottom, hours on the top, it goes away. And I'm left with seconds on the bottom. So now I'm left with the unit that I want, which is meters on the top and seconds on the bottom. Only thing on the top is meters, only thing on the bottom is seconds. And now I can plug in the numbers. So I have 30 times 1,000 divided by 3,600. And I end up with 8.3 meters per second. So 30 miles per hour is the equivalent of 8.3 meters per second. All right, well, what if I'm talking about acceleration? And I have an acceleration of 6 meters per second squared. And I want to know, what is that in meters per minute squared? That was what I wanted to know. How do I deal with a square in the unit? Well, a square is just multiplying the unit by itself, so I have to multiply the factor by itself. So let's look at that. We have 6 meters per second squared. Now, I want meters on the top, so I'm not going to even worry about the top dimension. If we wanted to worry about the top, we do the same thing on the top. But I do want to go from minutes to second. Now, I know that there's 2 seconds here on the bottom. I can rewrite this as second times second. So I need to get rid of both of them. I know 1 second on the top gives me 1 minute on the bottom, so 60 seconds in 1 minute. Well, that'll get rid of one of the seconds. But I'm still left with 1. So I need to do another 60 seconds on the top, 1 minute on the bottom. And And I'm left with by unit, meters is on the top, minute times minute, or minute squared on the bottom. So I have to do my ratios twice to get rid of those units appropriately. If it was a cube, 3 times. If it was squared on the top, I'd have to do that one twice. All right, so 6 times 60 times 60 gives me 21600 meters per minute squared is my acceleration. All right, so with unit conversion, again, the base is just that we're multiplying by 1, so we're not changing anything about the physical description of the quantity. And we're putting it into units for a different purpose, whether it's mathematical, algebraic purposes, or to communicate better across different disciplines. We have to keep in mind that if a unit is on the top, we want to get rid of it by putting it on the bottom, getting to the appropriate unit that we want on the top. And second, if we have a square or a power, any power within that unit, we have to think about those as separate entities, and we have to get rid of them more than once. All right, good job.